Good morning and welcome to Coffee and Compressed Air. We're episode 9 now. And I know I always say I'm excited about these, but each one is so different. I personally learned so much from each one. So I'm definitely excited for this one because it's something we've been talking about more and more with different people. And it is overwhelming. It is the demand side and exactly what data is needed to run a good demand side audit. So I'm going to let you start right away because I know the 20 minutes goes by so fast and there's a lot.
Yes. Hi, everyone, and good afternoon from Europe, from sunny Italy. So I don't have my coffee today, but I have water. So it is water and compressed air. Otherwise, if I drink Italian coffee espresso, it's going to be just a few minutes, a few seconds. So we will not put to have all this time. And everyone is talking, especially recently, that compressed air is a demand-driven system. Wow, what a surprise, right? That at first you actually use it somewhere in the facility and then you need the generation for that. Although still there are so many users pay attention only on the compressor room itself. Extremely important how your utility is generated, extremely important. But as I always say, if you want to reduce consumption of your house, you don't go redo something in your generator, right, or in your grid. You switch off the light in your kitchen. So that's the first thing that you have to do. So you need to see how the air is consumed and what is actually the demand side of that. I noticed it that it's extremely difficult topic for many people when we speak about the compressed air, and it is as difficult as it's difficult for me to talk about the compressor room itself, because I am a demand side expert. Everything after the door of compressed air room. This is my field, and the problem is there that we have so many applications of compressed air. So it's easier maybe like to get the layout of the pipes, although it's usually such a mess in the facilities, and it's okay, it's normal. The systems, they are growing themselves. So it's kind of like a living system there. But in the demand side, what it is important to see, it's an exact point of use. And by point of use, I'm going to be now boring and a bit theoretical, but okay, practical also. The point of use is basically if you go in the facility and you check the machines where the pipe of compressed air is coming there, where the air does the work. Any mechanical work, any work of the blowing work, where the air is cooling down, where it is cleaning something. And then you have a pneumatic equipment there. So pneumatic equipment, you even can go like online and check what the pneumatic equipment is. We also have some online lectures on this. So points of use of this pneumatic equipment and what it can be. It can be air knife. It can be air amplifier. It also might be vacuum application if it is not generated by the vacuum pump, but it is the air that is used the ejectors. So it also can be any blow-in applications, any nozzles, pneumatic motors, and one of my favorite also cylinders. So all these final points of use, this is where the air is used. And don't be here scared, because when we talk about the energy consumption of the demand side, we don't have to see every single component after this cylinder, after this air nozzle, after this air knife. It's not so relevant unless we don't have problems there. So this is this is like a secret now. So please, all my customers, close whom I do audits, close your ears, because I usually say everything is so important. So of course, every single component. I mean, yes, if you have some obvious issues, such as, or maybe not obvious issues, not enough air, or you see that there is a pressure drop or something is happening with this application, then of course it's important to see the components. But if you want to evaluate the demand side application, how the air is used, maybe there is also misuse of the air. I'm not now going to talk about the you see the phrase is like an artificial demand. Honestly, as a person who works for ISO and a project manager for the flow application and distribution and the pneumatic systems, um, I don't have a correct definition for this. So, every people saying that artificial demand is something that you use more than you actually need to. Okay, it is a demand that you. This is a demand, but then you need to understand how it is exactly used. So, I have a little bit like I don't have yet a formed opinion about this, and there is like not actually definition in the standards what it is. Some people say it's over pressurized. Again, big topic. Over pressurized. We'll have a separate coffee about this. But the air where it's not used correctly or like too much flow comparison to the supply side, I would say that just see first of all the points of use where the air is going and how the air is used, and this is the key. Understanding how, for what air is used for which operation, because you don't need compressed air for the sake of compressed air in the facility, right? How it is used, it is extremely important, because if you take, for example, some vacuum applications, you can easily replace with the solutions with the vacuum pumps. So there are many things that you can see and maybe replace some applications by alternative applications. So, and where the point of use, this is where the air is consumed. And consumption is built upon the level of the pressure that is required and the amount of the volume that compressed air has to fill. I love, Dani, how you're listening so carefully. Just, we need. I'm like I'm so happy. I'm so happy to have this kind of call, because like you're like the best fan of this kind of lecture. So anyway, I hope others also enjoy. So
I know
I
sometimes the other
everyone
people.
needs to have the face of Dani. So really, please. So this is why I didn't bring today also any else. I'll show you something now, but no like lectures or how does it. I mean, we have some videos and lectures about this, so everything, but I really love, I really love educational content. So the it's very easy. So you need to have the pressure level and flow, and then in order to blow somewhere in the end of the application to cool down or to clean, for example, a piece, you need to fill those pipes from the valve. The same thing we were talking about last compressed air, about the filling the pipes in the cylinders. So basically, so if you go on our YouTube, you will find, or our LinkedIn's, you'll find this. So the thing is that it's very logical that consumers will be something where you need to have a pressure and you need to have a certain volume to fill. It means that it would be cylinders that require the compressed air to move, right? Any pneumatic motors, it will be any blowing applications, any vacuum applications. I'm talking about any process valves where you need air to, for example, do some opening or closing of the starting the application, something. So this is very logical, so meaning that you don't have actually to build the entire pneumatic diagram of the machine. You don't have to, okay, I found the cylinder, and then now I need to understand what is the okay, piping is important, but valve, looking for the valve island, looking for any other throttle and check valves. It is important when you design the new machine, when you want to see the functionality of the machine. But if you want to do the demand side analysis, it is enough to find what is here a consumer. So what consumes here air? And what is this? This is the first part. The second part, it's important to see at what pressure level this consumer works. And for this, we also had one of our shows, I would call it, where we explained that you need to see the closest pressure regulator. So the manometer there that is installed, pressure gauge that is installed close to the application. And then once the cylinder, for example, starts to move, then you see if there is the pressure, where is the pressure drop is happening. And for example, if the arrow moved from 5 to 4 bar, it means that there is at 4 bar your application here works. So this is the pressure level of the application. So it's your application probably is not running at the of the compressor room level. So it is completely another story. So, and then basically the next step to see it is the what type of the consumer it is. So I always call them as a consumer. And the next one is what is the timing of this. So meaning that you have the pressure, you can estimate the flow when you know the what types of the consumer is, and then for example the cylinder does the one stroke in 2 seconds, in 3 seconds, in 5 seconds, and then goes back. So once you know how many strokes per minute it does, you actually can already understand the whole consumption per hour of this machine. If it is doesn't usually it's not something super particular. So,
Mhm.
and basically what we're doing now, and if we have a tool, I'm going to share my screen now. So we have a tool, and I explain how I usually do audits. So let me just go. Sorry, I need to share another screen. So if there are so many questions while I'm opening the tool, let me know.
So we did have a comment. I can put it here.
Okay.
I Yeah, I think this was for the artificial
The
demand
original
machine.
definition was the excess molecules used because air pressure was high and required that the evaluate the pressure due to the pressure drop that you've been piping. Yeah, so basically kind of yeah, I understand. I still honestly in the standardization it's used the pressure that is required for the application. It calls now in the new standard that we're developing, it calls the working pressure or application pressure, but it's not like an artificial demand. So it's a working pressure for the application, how much the application requires, and then from that backwards, the pressure drops are calculated, energy losses are calculated in order to calculate the required pressure level and the flow for this application. But I think it's actually a very good point. So maybe we can have some another coffee and compressed air also based on this, and I can share some new things that are happening in the standardization nowadays. Do you see my screen now, right?
Now we do.
Yes.
Yes.
Okay, perfect. So imagine that. So the tool, basically, the logics that is usually followed for the demand side optimization is the first. I mean, everyone does. So first, it is the first we do some design, right? So we have a layout. So we download this layout. We can draw something here. You have a compressor room, and then, for example, you have here, I don't know, 3 production lines. Sorry, I'm not using my mouse today, so it's my art. So, and basically, once we do the analysis of the consumers, and without like being overwhelmed and create all the possible PID diagrams of the machines, we can analyze the distribution, the piping. So we can put the piping segments that you have there. We can put the air path segments from the consumer, information about the supply side, about the compressor room, and then this is basically what I call demand side or what is called demand side. It is the consumers. And for example, you see that you have here 3 production lines, and the first hotspot or the first consumer here will be, for example, we see the uh, consumer type. So for example, we see an air knife or cabinet cooler cylinder. So here you can see all the possible, or blowing gun. And here we collect information, which assembly line it is, what pressure level it is, what are the some additional information, and basically populating the diagram with these hotspots and analyzing the demand side. So then you can go into the consumer itself and, for example, put here the photo of it, the video. What is important, the information will be here. If you have an open blowing, here is the uh, what is the diameter of the tube, how many of them, and this is the cycle time, basically when it's on, when it's off, and in this sense, put also some preliminary information. What are the pressure levels of this, and so on. So this is helps to gather the data even maybe before any monitoring is happening. But once you have the any monitoring installation, so then you also can enter here the information from the meters, from the loggers that are here, and after this the summary. So from that, it helps actually to collect and to analyze the demand side better. And this is why I think it's extremely important not to be so scared and overwhelmed, because some people usually tell me, you're doing like it's a very complicated thing, it's very complex thing. It's actually not. It's don't need to have all the possible connectors there, or quick couplings, or calculate the velocity of cylinders. So it's not necessary in order to understand how much there will be consumed, because their consumption depends really on the volumes that are filled and the pressure level that are required for this application. Important to understand what is the actual pressure level for this application, and then already to see the possible optimization. So this is just a very, very, very rough information, and this is what is very important for the demand side. So after the demands, after we gather this data about the consumers, or of course better if like we can measure also the consumptions there, then we need to we can already analyze the thing. But unfortunately, of course, just by analyzing the generation side, it is extremely, extremely hard to understand what the possible optimization will be on the demand side, because at the end it will be the demand driven system. I see here there is, it used to be called the article pressure.
Mhm.
Yeah. It's
Yeah,
in
that's
the new standard it will be the working application pressure, the working pressure. But yeah. So this is basically the pressure at the application.
mhm.
Yeah. So this is a very, very, very short express thing. And yesterday we posted a video on our YouTube, and I think we can send the link to this video, where
Mhm.
there is an example of how we build the model based on this consumer gathering, right?
Mhm.
Consumer gathering sounds like a party, but consumer data evaluation. So consumer, I don't know, collecting data about the consumer. So what I just showed you, so basically go we see where if there is like open blowing, if there are like any rails with the holes, cylinders, and exactly this information then can be now it can be actually exported directly into the our software, into the EasyCAS, or you can have a perfect automation device that's called Elvira. So I also can export it and if it is interesting to simulate any production lines. But
Mhm.
again, I just want to, especially users and the not producers of the machines, but end users, in the facility managers and operators, don't be afraid to understand what is actually inside. It's not a
Mhm.
rocket science. Like pneumatic system design, it's not something that people really put a lot of thought in it. So the pressure levels that you actually need at the machines, it's not what you need. And we can talk also about this next time. For example, for a lot of cylinders, a lot of manufacturers tell that here has to be 90 psi, 6 bar, 6.5 bar, then everything goes wrong. No, it will not go wrong. The cylinders, and that's a very big secret, they work on the pressure difference and not on the absolute pressure. So, and this I also can, next time we also can see about the various consumers, how they actually can be analyzed and optimized. Wow, 20 minutes.
Yes, right on the dot. Yeah, so I really like this podcast because I know it's weekly and it feels really fast for us, but there are unlimited topics to talk
Yes,
about.
they are.
I think we have 4 now booked from just this one, that we need to do. So that's a whole month.
We
Next
also need
week,
to invite Paul Edwards as a
yeah,
guest to one of our compressed coffee. So, Paul, you're welcome.
of course he is. Yes, we know Paul. So that would be great. Next week, I will be at Compressed Air Best Practices, my first time. So I'm really excited. We already have lots of meetings booked and people that we want to meet. So I'll go ahead and put out a schedule, kind of like where I'm going to be. So if you have any questions, I'll be there with some information or just to say hi. I really like meeting people who I've seen in the comments and had conversations with here in real life. It makes a really big difference. And next week we have John from Air Pipe, so people know him. So we will be live on live next week from from compressor best practices. So make sure to stay tuned for that and we'll get something posted up here shortly. All right, thanks
Perfect.
everyone.
Thank
We'll keep
you.
it at the 20 minutes and everybody can get back to work. Thanks everybody.
Bye. Have a good day.
Bye.